This is Mr. Wright. Today we're going to go over isosceles and equilateral triangles, their properties, and how you use those properties to solve for missing parts of triangles. So first off, isosceles triangles. So what's special about isosceles triangles is that two of the sides are going to be congruent. So in this example, these would be my two congruent sides. So when we have two congruent sides, if you think about like an isosceles triangle, because two of the sides are congruent, there's going to be a line of symmetry in the middle. If I fold over the triangle on that line of symmetry, you'll see that these angles, these two angles, would also match up. So that means that there's also going to be two congruent angles in an isosceles triangle. Those two angles are going to always be the two angles that are across from the congruent sides. So it works both ways. If you have two congruent angles, then that also means that two of the sides would have to be congruent. So let's look at a couple of example problems. So again, if I have an isosceles triangle, the two angles that are across from the those two congruent sides are going to be congruent. So these two angles will both be 81. Then using what I know about triangles, all three angles have to add up to 180. So if I did 180 minus 81 minus 81, you would get 18. So the third angle would have to be 18. This one is similar where you know that this angle would also be 51. Those are going to be congruent. So then you can solve for angle Q. This third example, they don't give me one of the congruent angles, but I know that angle S and angle U would have to be the same. So if I have the top angle, I could do 180 minus 68. That gives me 112. So those two angles would have to add up to 112. Because they're congruent, I could do 112 divided by 2 and find out that both of those angles would have to be 56. Because 56 plus 56 equals 112. So just make sure that you are aware that even if the isosceles triangle is like on its side, that you can still identify the congruent angles. So it's always the two angles that are across from the congruent side. So in this example, A and B would be congruent. And then same thing if we're starting with two congruent angles, the two congruent sides would be across from those angles. So this side and this side would be your congruent sides. So then you can use these properties to do like equations. So for example, in like this first example, if I know that this is 28, this side's 28, so to set up an equation in this example, I know that all three angles in a triangle would have to add up to 180. So my equation would be 5x plus 9 plus 28 plus 28 equals 180. Then you could solve that equation to get x. The next example, the two angles that they give me are my two congruent angles. So this time I'm not using the 180. I just know that those two angles have to be equal. So my equation would be negative 4x plus 9 equals 8x minus 3. And that's the equation I would solve in order to solve for x. Then once I have x, you can plug x back in to figure out what each angle is in that triangle. So you're just looking for like what's that relationship. If you have two congruent angles, that's how you write the equation. If not, all three angles would add up to 180. So then you could also have equations that deal with like sides. So if we look at this one, I know that if I have two congruent angles, then the opposite sides are the two sides that are going to be congruent. So this side and this side would be congruent. So the way that we write the equation is 8x minus 1 equals 4x plus 5, because those are my two congruent sides. So I could then solve that equation, figure out what x is, and then I plug x back in to figure out all three sides. One of the common mistakes I see with students is that sometimes they would try to add up all three sides and say it equals 180, but that doesn't work for sides. That only works for angles. So if you have sides, it's not going to add up to 180. Sides of a triangle. So those are equilateral triangles. Those are isosceles triangles. And then equilateral triangles are when all three sides are equal. So if I have 3 equal sides, if I use like my lines of symmetry, then that means like when I fold the triangle over, the angles are going to match up. So like this angle would match up with this angle. If I use another line of symmetry, then like this angle would match up with this angle. And then if I fold on the third line of symmetry, then this angle would match up with this angle. So pretty much what that means is that all 3 angles are always going to be equal in an equilateral triangle. So if you do 180 divided by 3, you get 60. So all sides are congruent in any equilateral triangle, and then all angles are always going to be 60 degrees. So let's just see how we can kind of apply this. So if I have multiple triangles together, this triangle on the left, ABC, this triangle, I notice has 3 congruency marks. So that means that it's an equilateral triangle and all angles would have to be 60 degrees. Now the other piece of information they tell me is that the measure of angle CBD is 130. So that means these 2 angles together have to be 130. If I know that, then I can do 130 minus 60 and get this angle is 70. Now this triangle on the right isn't equilateral. This triangle on the right is isosceles because there's only 2 congruency marks. So if we go back to our isosceles rules, if that angle is 70, these 2 angles have to be congruent. So I would do 180 minus 70, I get 110. Divide that by 2, I get 55. So that means both of the top angles would have to be 55 in this example. Here's another example. This one doesn't have an equilateral triangle. There's 2 different isosceles triangles. So with this one, we have the 72. I know that this angle and this angle are going to be congruent. So I would do 180 minus 72. I get 108 divided by 2, and I get 54. So both of these angles are going to be 54. Okay, now this example, we have this angle and this angle together, they form a straight line. So they would have to be a linear pair. So if I do 180 minus 54, I get 126. Okay, so these angle relationships are still going to pop up, the ones that we did in Unit 2. So then we have another isosceles triangle on the right-hand side. So I know in this isosceles triangle, this angle and this angle would have to be the same. So I would have to do that same process where I do 180 minus 126. That would give me 54. Divide that by 2. Now we get 26. So these 2 angles would both have to be 26. This is how, so then we have a couple more kind of the same thing. Just remember, if you see an equilateral triangle, all 3 angles have to be 60, like in this example. And then if you have an isosceles triangle, 2 of the angles are going to be the same. So I know that these 2 angles would have to be the same in this triangle because it's isosceles. And if I have a straight line goes straight across, then this angle would have to be 120 because it adds up to 180. And that would give me, so if I do 180 minus 120 divided by 2, both of these would have to be 30. So that's how isosceles and equilateral triangles work.